Hello good people, welcome back to SolidWorks commercial kitchen equipment design. In our last video we spoke about a simple layout which I promised to design all the fabricated items found in this layout, and we are going to start with item number 1. And our item number 1, like I promised, I'm now going to try to design the imported items, but I will go straight away to the fabricated items. So item number 1 is freestanding digital weighing scale, which is an imported item. We are not going to do that. So our item number 1 becomes goods receiving table or sorting table. So let us look at a simple design of a receiving table, and if I could pull a photo of the same and show it to you, this is how a receiving table looks like. Receiving table looks like this with a chute, but this is a receiving table on dishwash area. It has a big chute where you scoop or scrap down the leftovers on the plates down to the waste bin. You can see right under the receiving table there is a waste bin which is on wheels. Basically the sorting table is more or less the same as the receiving table on the dishwash area, the only difference being the chute. In the goods receiving area, it doesn't necessarily have a big chute like this. Well, there is no harm in having a chute like that, but again it will take some space which can be occupied in sorting the goods received. So instead of doing a big chute, we are going to do just a small drainage at the center. Right, let's take a look at the So this is basically the drawing of the receiving table, and the size is 1800 by 700 by 850, 860 there. It has a rubber adjustable rubber grommets, which I have not indicated. Actually, I have not done them. Well, that is something that you just insert. It has a band. This band here, what you can see here is 50 millimeter. As you can see it from the drawing, it's 50 millimeter, 50 millimeter or round, 50 millimeter or round, and it has can I call it a depression of 40 millimeter. And again, as you can see, the bracing, the three sides, the two sides and the back, it is at a height of 200, but at the front it is at a height of 650 to give clearance for the waste bin, so that inserting the waste bin under the table there might be no issues. The total height of the waste bin is between 600 and 630. 600 and 630 is enough height for a waste bin. So we want there to be a clearance. Now, also something that I might not have mentioned in my previous video is that the depth of the items many a times are determined by the depth of the imported items, like the under-counter fridges. And in under-counter fridges, well, there might be something different, but what I have encountered in my years of dealing with commercial kitchen equipment is that they come in two series, a depth of 600 and a depth of 700. So when you're doing your fabrication, when you're doing your designing, you first check the imported items, what series are there in the market. If you find that whatever size you're looking for, they have a series of 600, then it is always important to do your designs, fabricated items, to have a depth of 600, because you don't want there to be edges protruding. You know, the under counter is 700, you have designed a sink of 600, there will be a 50 millimeter edge protruding here and elsewhere where they will be coming next to each other. So and that is a safety hazard. So you ensure that all your items are in one continuous straight line. And again, you cannot ensure that the front they are in a straight line by offsetting, say, the sink. Is it blocked? No, it's not blocked. By pushing the sink forward so that they may be in one line, hence creating a gap, an opening sort of between the wall and the item. It doesn't work like that. So if they are going against the wall, all of them should be touching the wall, and at the front a straight line. Okay, there you have it. So in my case, most of my items will be having a depth of 700. Okay, 700. And again, the reason why we do the bracing at a height of 200 is there to be enough clearance so that when the people are cleaning the floor, it might be very easy for them to clean the floor. All right, the clearance is enough to do cleaning of the floor. If I could zoom it a little bit, and yeah, see, the clearance is enough to do the cleaning of the floor. Okay, so again, let me pull the drawing. Yeah, right now here my highlighter, this, we zoom it a little bit. This is that part that I have highlighted is a skirting which hides the one below. Okay, not the one up there. That skirting hides the channel that will be carrying the legs. Is that the right term? The legs. Yeah, the legs. Okay, let me pull an animation of the assembly of that thing. Let me pull an animation of the assembly of the table. Yep. Where's the folder? SolidWorks tutorial GR1. Yeah, here is the animation. There you go. You can see this is the top. Just 1 second. I freeze it. There. Yes, let me freeze it up there. Now here is the top. This is the top. These are U-channels which, you know, you will be welding your legs. The top of the legs will be welded on the U-channel. Yeah, because you don't want to weld them directly on the top, and the welding will protrude on the top and it will be difficult to polish. And even if it wasn't difficult, there is no point of doing a polish here, doing another polish here, another polish here, and another polish here, because the material is very clean. So you don't want unnecessary polishing. So instead of doing that, you do U-channel, which actually tend to act as backing. They give it some mechanical strength. The top, they give the top mechanical strength. So you stick this to the top by use of what we call macroplast adhesive. Macroplast adhesive. Yes, macroplast adhesive. You stick this, put some weight on the channels, let it set for a couple of hours, say 3-4 hours. Well, if you want it to set well, you put you stick them, put weight, leave them overnight. Tomorrow that thing will be completely stuck on the top. Yeah, no welding there. Now once that is done and you have done your welding, you don't want these channels protruding, not protruding but visible. They will look ugly. That is why you can see I have some pieces on this side, on the other side, and on the other side. These are what we call skirting. It might not be the right term. Some people might call it cladding, some people, I don't know, but I prefer skirting. I'm used to skirting. So you do some skirting to hide this channel. And also, if this was receiving table of the dishwash area, you don't want the chute protruding from under here. Yeah, you don't want people seeing the chute. So the skirting takes care of that. Let us complete the animation. Da-da-da. There you have it. Yeah, there you have it. There is your receiving table. So let us go right into SolidWorks. The designing of a receiving table, we will go to File, Open New, Part. You can see my templates. I have two parts, Part and Part 2. The reason why I have Part 2 is because my software had the defaults were at inches, and we are used to doing metric because we were colonized by the British people, right? So our system is British system, so we are using metric. So I decided to come up with a template on millimeters as my standard unit. So I go to Part, click OK, then go to top plane, start my sketch there, go to center rectangle, ensure that it is from the origin to a rectangle, smart dimension. This is 1800. Sorry about that. My mouse is not working really well. I will fix it. On the side of 700. Wow, my mouse. Yes, 1800 by 700. That is the overall size of the receiving table. You exit the sketch. Exit the sketch. Isometric view. There is something that I should have. Yes, what I wanted to mention is that we will basically be dealing mostly with sheet metal and weldments. Sheet metal and weldments. Okay, sheet metal and weldments. We'll, at a later stage, we will take a look at the other, what do we call them, functions in SolidWorks. Now, having done that, you come to top again, then go to reference geometry, create a plane. Your plane, you can offset it to whatever distance you want. This distance is not so important such that it has to be fixed to this or that. No. You just offset it to whatever distance you want. You can do 50 millimeter, you can do 10, you can do 100. In my case, you do a distance of 100. Create new. Then from the new plane, I create my new sketch. Normal center rectangle. I will center it completely from the origin, then do my rectangle. Okay, let me pull the drawing real quick. No. Yeah, so you can see there is this bend on top here. This surface here is 50 millimeter all round, as you can see. So that means that from here to here, from that line to this line, is 1800 minus 50 minus 50, which is 1700, and this is from here to here is 700 minus 50 minus 50, which is 600. So as we dimension our plane, our sketch, our new sketch, we'll dimension it from the first sketch and do 50 millimeters. Okay, 50 millimeter, 50 millimeter. And since select, okay, since the rectangles are centered completely, they are coincident at the origin, it will adjust itself equally on this side and also on this side. If you were to do a dimension on this other side, my mouse, forgive my mouse, I'll make sure that in my next video I will have fixed my mouse. And wow. The mouse, yeah, just bear with me. I will make sure that in my next video I will get my mouse fixed. Yeah. See, this and this, because the two rectangles are centered from the origin, so you dimension here, it adjusts itself equally here. You do the same here, the same happens on this other side. Now you can go to your sheet metal and do base flange. Base flange, and the thickness of the material is 1.5 millimeter. 1.5 millimeter. You don't want to do a table with a top which is not strong enough. You know, might be carrying a lot of weight. The goods that are coming from the goods that are being received in the kitchen, and they having a lot of weight. Sure. Okay. With that done, now you can hide your plane. When you go to edge flange, choose this edge, stick it on the upside, this edge, and this edge. Give it a radius of 0.2 millimeter, the gap 0.1 millimeter. Keep material on the outside, bend allowance, you take it K factor, which is default to 0.5, then custom relief, it's there. Okay, then click OK. Did we give the bent? We didn't give the bent dimension, so we hit the edge flange, and the bend should be 50 millimeter. 50 millimeter. Click OK. Okay. Now you don't want here to have for you to be having a big gap. It's just about 0.1 millimeter is okay, because the welding will be done from here outside, not inside here, and you don't want the welding to penetrate, a lot of welding to penetrate on this other side, the face side. Polishing will be very hectic. Having said that, we go again to edge flange, choose this edge, direction, that edge, this edge, that edge, that edge. Well, there is no harm in giving it some dimension, but again, if you give it dimension and when you're doing the bend that is going downwards, the radius will make it slightly bigger, so it is better you do it up to vertex. Don't worry about the vertex, just click OK. Once you click OK, come choose one of the faces and edit the sketch, and choose the line and the line from the first sketch and make them collinear. That will adjust the other bends equally, and this bend will be about 50 millimeter. Now, the purpose of sketch 1 was for us to make this edge and the overall dimension collinear, so you can hide your sketch so that it may not bring confusion. Now we go to corner, closed corner, we choose closed corner, and we choose this kind of corner. Okay, so we choose this. You don't need this face, delete this face and this face. Then this face matches with this face. You can do all that to the other corners if you want, or you can have those two corners, click OK, you have closed those two corners. Then you go to the right plane, highlight it, features, then mirror the closed corner that you initially are done. There you are, your top is almost done. Then again, back to sheet metal, edge flange, choose this edge, this edge, this edge, this edge. Again, radius of 0.2, a blind of 30 or 40 mil, and all the other factors remain constant. Click OK. Then you have a 15 millimeter bend going on the inside to avoid a sharp edge. To avoid a sharp edge here, you will require to do a bend of 15 millimeter. Let me do here 15. You can do 10, you can do, depending on the bending machine that you are having, but ideally 15 millimeter is looks well, looks neat. All around edge flange here, 15 mil. 0.2 again, 0.2 radius, and the other factors remain constant. There you go. And your top is almost ready. The only thing that is remaining here, the top is ready. The only thing that is remaining is doing a cutout for an opening for the drainage. Okay, opening for the drainage. So you click on this face, click new sketch, take a circle, do a circle there. You can do a circle of 1 inch, 1.5, 2 inch, 2 inch would be ideal. Yeah, let us do a 2 inch drainage. that will be dia 50, actually 2 inches, dia 51, dia 51. Okay, what's going on here? Dia 51, yeah, dia 51. Click OK, go to feature, extrude and cut, link to thickness. There you go, you have your drainage opening and your top is done. You can give it smooth edges, shaded. Yeah, if you want, you can choose material, appearance, material. It's metal, it is steel, stainless steel, polished steel. Right click, add appearance to part. There you go, your stainless steel top. Then you can save it as part number 1, project work, a solid tutorial. I will do it 1 G. What's going on? GR2, call it top. Save it. Yeah, the top is done. The top is done. Now, why we were doing this cutting basically is to hide this part and the channel that will be on this part, to hide it so that it may look neat. Okay, you will see it by the time we are done with the video. Right, so let us go do part 2, which will be the channels that will be that will do the welding of the legs on. Okay, so we go to new part, click OK, plane, stop, plane, center rectangle. Okay, now what is the size of the channel that we are going to do? The channel, okay, let me just, we will edit it. The length of this is 1700. You know why it's 1700? Here we can do about 15 plus 15 is 30. 30 plus 38, that is 68. You can do it at 70 millimeter, 70 mil. Click OK, sheet metal, base flange. Yeah, the channel has to be 1.5 to give it some strength. Now go to edge flange. Those two sides, give it 30 millimeter is okay. Default radius, but this you don't have to worry very much about the default radius here, and the bending allowance, the custom relief. This is something that doesn't have a lot of bends and all that. Now we do another edge flange here. This should be 15 mil, and on the other side 15 mil. Okay, now how did I come up? The most important thing as far as the channel is concerned is not this size, it is this size. Go to tools, go down to evaluate and pull up our measuring tape. Our digital measuring tape. SolidWorks has provided us with a digital tape measure. Right from there to here, it should be right around 38 foot, because we are going to use round legs of dia 38, and you want to do your welding. Once you insert your legs touching to this surface, you will do the welding here and welding here. You can do a small stitch weld on this, on the sides, okay, but the important welding will be here and here, so you don't want a big gap when you're doing your welding. That is why I took 38 plus 15 plus 15, that is 68. That gave us this height. Again, doesn't matter, but again, you don't want to have a big height here. It will lead to you having a huge skirting and the thing will look ugly. You feel me? It will look ugly. Now, with the channel done, you can go ahead and add some material. You choose appearance, metal, steel, polished steel, right click, add appearance to part, then you save it under projects, SolidWorks tutorial, GR, and we give it as part 2, GR2, you call it channel. Okay, there we go. Now, as is custom of me, every time I have two parts, I normally go ahead and start the assembly, right? Then the other parts I will be designing, then assembling as I continue. Therefore, I will start a new assembly and do my assembly right away. And the base part will be the top, okay? So we go ahead and open the top, place it, then insert component, channel. There you go. Met this face mates with this face, and this face should be parallel to this face, and if I can open the top, the right plane of the top mates with the right plane of the channel. Sure. And our channel is in place. Now, if you can see, the reason why we are putting this channel, I think I have explained, but let me elaborate right now that you can see where the channel is that the legs will be here. The top of the leg will be inserted right here, and you see, if you were to put the leg on this end, if I could start a dummy sketch and I do a leg of dia 38, something like that, then I'm not sure that this will work. Yes. Oh. Okay, tentatively let the leg be there. Now, if you're doing the welding on the top right here, the welding will penetrate to the top, and you see the leg should be right here at this edge, and polishing here will be hectic. Polishing here will be really hectic, and you will put tool marks all around this face, and you don't want to have an ugly table, right? That is the reason why we are doing, let me cancel the sketch. That is the reason why we are doing this channel here, so that when the leg is inserted here, you do your welding on this edge and on this edge, and probably just a small one, a small stitch weld here and a small stitch weld. Once we insert the legs, I will show you. Yeah, hope you are gaining something. Therefore, what you are going to do is we'll pull the front plane and mirror components, and the component to mirror here will be this channel. Okay, right there you are. Now let us go ahead, and there is no need of putting a channel here. There is no need, especially if you have used a 1.5 sheet. There is no need of putting a channel here, but if you want you can do it, but I find it a waste of material because your leg will be here, the other one will be here, and the other one here and here. If you want, do a channel here, but it's a waste of material, right? Now we want to design the skirting, and as I was saying, if you leave this thing without a skirting, this part will be visible and people will see something which is ugly. It won't look nice. They have basically the channel, the skirting. Where were we? Yeah. The skirting is to hide this. This is the skirting, and it is hiding that channel. Can you see? It is hiding that channel. You cannot see the channel once the skirting is there. Okay, so let us go back to our drawing. Now, what will be the size of the skirting? The skirting. We pull our digital tape measure. This is one tool that I normally use almost in every drawing that I'm doing, especially the assemblies. One tool which comes in handy. I really appreciate this measure thing. So I want to measure it because the skirting will be touching from here to here. So that's about 84.5 millimeter. 84.5 millimeter. So we can do a channel, a skirting of 85 millimeter. Okay. So let's go ahead and do new part. Okay. We go to front, new sketch, center rectangle. From the origin dimension, we dimension it at 85, right, 85 millimeter. The other channel, the channel that will be carrying legs is 1700, so we can do this at 1702 or 3 millimeter. Yeah, 4 millimeter, so that it may protrude on this side 2 millimeter and the other side 2 millimeter. Okay, then we go to sheet metal, base flange. This can be a channel of 1.2. You can use material of 1.2 millimeter. There is no weight that it will be carrying. It's just for beauty only. Then we do a edge flange. This edge flange goes to this side, and it's 15 millimeter. And the other edge flange goes on the opposite direction, 15 millimeter also. Yeah, so the channel will, the skirting will look like that. We had material. It is also made of stainless steel. It's about that. Save it as part 3, part number 3, GR2 hyphen long skirting. But you can save it under whatever name that you want. Then we go back to the assembly and insert component. We are going to insert the long channel, right? So this channel, we made it, like I have mentioned, this part, this face will be lying onto this face. Okay, then the inside of this face meets with this face. Okay, then the right plane and the right plane of the skirting and our receiving table is starting to take shape. Click OK. It is starting to take shape. If you can see, there is a small gap. You don't want, okay, again, you don't want the gap to be very big, and you don't want it to be very tight, right, such that it will be hanging on the top. And remember, there is no welding that should be onto that channel on the top. We don't want any welding which will be protruding onto this surface. The only welding that is allowed is the one that will be along this joint, right, along this joint. You want to have minimum polishing, okay. We pull again the front plane and mirror components, mirror component and a component to mirror his skirting. There you are. We pull again our awesome tool, tape measure. I really appreciate this tape measure. I don't know how many times I'm going to say that, but I sure do. We are measuring between that and this so that we may get the length of the small channel, which will be 605 millimeter. Therefore, we go to new file, new part. Okay, we go to the right plane this time round and do new sketch, center rectangle. The width or the height of it remains the same as at 85 millimeter, and this we have seen should be 605 millimeter. Sheet metal, base flange, material, same material. Click OK. The edge flanges are the same. This one goes to the outside, 15 mil, and the other one goes on the opposite direction, 15 millimeter. It's the size of that bend, and you're done with the skirting. Material again is polished steel. We are done with that. Go ahead and save it as part number 4. Part number 4 is GR2 short skirting. Okay, go back to our assembly and insert component, short skirting. There we are. Met again this surface, this face meets with that face. Click OK, and this meets with this. Click OK. We'll go back. To the front plane and front plane of the short skirting. Click OK, and you're done. We want to mirror components. We go to the right plane, mirror component to mirror here is the short skirting. Right click, OK. Now the top and the skirting and the channels are done. The only thing that is remaining here is the legs, and as you can see, you cannot see that ugly channel. And as I was saying regarding that bend of 30 millimeter, you don't want again this to be really big. One might confuse it from a cabinet, right? From a cabinet. But that's about that. We save the assembly as GR2 assembly. Good. Now we are supposed to design the legs. I will design the legs, the whole, the frame, the legs and the bracing and all that at once using weldments, right? Weldments, file, new, part, click OK. Then I will go to weldments. Disclaimer. I want to give a disclaimer. I intend the legs, we many a times use round tube of 1.5 inch dia, which is dia 38, right? And as I was doing my practice with weldments, I did not see the size of that tube in the templates. Therefore, if there is anybody who knows how to do that, please leave a comment, help me out, so that tomorrow, I said, we are whole learning. Okay, we are whole learning. Now our weldment, I'm doing a 3D sketch, and in the 3D sketch, let me try to bring the origin to the center of the Is it possible to make this coincident? Sure, it is very much possible. The other one, we can. I don't want it to be on the origin because I want. What did I do? Tab. Yeah. This. This. That. And that, and make them. Oi. Let me take that again. Yes, that is what I was looking for. Sorry. I'm yet to become a guru in weldments. I want to call my assistant. And my assistant is. This is my assistant. Where are you, my assistant? Evaluate, measure. I want to measure the outside of this, where the leg will be touching from there to there. That distance is 570. Remember, 570. And from here to here, that distance is 1673. 1673. So I'll put my measurement here. My dimension is 1673, and this one is 570. 570. Sure, that is very nice. Now this and this, we can make them construction lines. Okay. Now if I do a line here, it's a lot of work. Tab, then I choose this line and this line. Sorry, should not be that line. This line and this line, and make them equal. Then I choose this and this, and I make them midpoint. Oh, I didn't want it to do that. Can I undo? Yes. I take this point and this point, make them coincidence. Sure. And I do the same on this other side. Select this line and this line. They are equal. And are they parallel? Parallel. Yes. Then I take this and this point and make them coincidence. Right. Yes, that's good. Tab. Okay. Line again. Okay. Then I make this point and this point. I make them. Can I merge the points? Yes. Also this point. I didn't want to merge the points. I didn't want to merge the points, but it's okay. Can I offset? You cannot offset. We give this dimension to be, we are going to edit this once we put our legs and see whether they are in agreement with the total height of what we are trying to do. Equal. Then another line here. Select line, select, then we will take this, this and this, all of them to be equal. Beautiful. Now remember we have a skirting. We take this line, tab, up to there, tab again, up to here, tab again, up to there. Okay, this line This line will be what? They should be construction lines. In fact, let us not do this at 650. We do one more line from here to here. Click on, no, delete. This we are going to do it at 750. This, let us edit it to 750. Wow, I really need to do some more practice on weldments. And guys, the gurus that understand the weldment better, you can help me out. Let's see whether this line is parallel to this line. They are parallel. Now, a smart dimension from this line to this point, we need a clearance of 200 millimeter. And the same as this one to this, it's the same, 200. And from this to this, no, from this to this, it's okay. Now this smart dimension, this to this should be 650 to have clearance for, and we exit this sketch. So we go, remember we are in weldment, so we go to structural member. Structural member, this is where I had my problems. Pipe, we are using pipe configuration. We don't want angle line, we don't want C channel, we want pipe configuration. We don't want rectangular, we don't want S beam, we don't want square configuration. We want pipe let me see what is there in the square configuration. But I really, 40 by 40 we have, the thickness is not what we want. The thickness should be 1.5 millimeter. This is 4 millimeter. This is not what we want, okay? This is absolutely not what we want. Alright? So we are looking for a round tube. And a round tube, whatever sizes they are, whatever size is closest to what we need is 33.7 millimeter. Okay, we will go with that. The first group. Second one. We still go ahead and do structure. This and this. Oh, this and this. Something is not about right there because you don't want them. You are just going to notch this, not, and this is, I think that is wrong. Let me undo that. The size of the next structure, the bracing is smaller, dia 25, and the closest is dia 26. I don't know. I will just do that, but we can do one group. Structural member. We'll do this eventually. Click OK. We'll go back again. Eventually. Click OK. Yes. We'll do it again. Eventually. Okay, and again, too much repetition there. Eventually, and click OK, and our structure is okay. But we are going to edit this sketch. This sketch, we are going to edit it 570 minus 33.7. I hope you know why I'm doing that. And if you don't know, well, kazi kwako. Where's the other one? If you don't know, 73 point. What am I doing? Today I'm not there. I'm not as sharp as I. 33 3.7. I don't know whether I woke up on the wrong side of the bed or something. Today I'm not as attentive as I usually am. Good. Our storage seems to be done. We hide that sketch and we come here and save our part as part number 5, and it's GR2 hyphen structure. Structure. Click OK. Material is still the same, but can I give it a different color for the purposes of explanation? Can I give it some different color for the purposes of explanation? Black doesn't look so good. Blue seems... let me go with blue. Of course, you know there is no stainless steel colored blue, okay? Yeah. Now we go back to our assembly. We insert component and we are going to insert the structure, our blue stainless steel structure. Don't worry about the height. You know, the beauty with SolidWorks is that if you feel like your dimension, your measurements are not in agreement, you can always go back to the sketch and edit it. So we met this. Because we met this top sits right here, okay? And if I'm not sure about whatever I'm doing, but let's try and see whether it will be in agreement with what we are doing with the right plane. Yeah, it is working. And the front plane and the front plane. See whether we will achieve what we are looking for. Yeah, that is so much nice. Now the reason why I subtracted 33.7 is the diameter, because our sketch was running right at the middle of the tube, and then half of 33.7 and this other side 33.7, so we subtracted a whole 33.7 so that it may be touching where we want correctly, right? Yeah, so like I was saying, here is where you will be doing your welding. Your welding will be coming here and here and here. But if you can see this gap from the inside is a little bit big, because this tube was supposed to be dia 38, not 33.7. And that is something that I'm yet, maybe there are some hands-on I need to download and install to my SolidWorks. But anyway, anybody who knows why I didn't get it right from the first time, you can holler me, put a comment in the comment section. Now, why I did 650 here is because the height of the beam, you might want to do a beam later. You might want to do a beam instead of a drainage here, okay? So if you want to do a beam, which can go under there, and the bracing won't be acting as an hindrance. Or if you want to store your crates under the table on the floor, that's okay. If you can still change the design, and instead of having a bracing here, you bring the bracing down there and you put some slated shelf. You do a shelf which is slated. You will be having some storage space. But since you are expecting there to be water, you don't want the dirty water to be mixing, to be splashing on whatever you want to store under here. But so many choices, and these things, like I said, you design them and fabricate them as you want, and in agreement to what the client wants. Okay, now let us confirm whether our height is appropriate. We can play around with the dimensions of the structure. My friend is always there. She knows that I love her so much. I keep calling every now and then. Now you see, our normal distance is 804 millimeter, and we need this total height of this table to be 860. So we are short of 50 millimeter. But I'm not going to do it 50. I will do it at 830, so that we may give allowance for the grommet. Like I said, grommets are always 30 millimeter, and you need it to be short. You need the table to be slightly short. Once you fit the grommet, it to be 840 there, so that you can adjust it to 850, 860, depending on whatever size you feel like is good for you. So we pull the structure, go to this 3D sketch and edit it. This is one of the most beautiful thing about SolidWorks. If this design, if we were doing our drawing in AutoCAD, my friend will be making so many changes just because of a small thing. Be making so many changes. It will be very, very tedious. Yeah, be very, very tedious and time wasting. So with SolidWorks, original sketch, edit, and there you go. Your table is set, done, and the only thing that is remaining there is to do the grommets, right? And since all the items, the tables, the sinks, all those items, most of those items, you are going to use dia 38 tube. Somewhere along the tutorials, we are going to do a grommet. We are not going to do it now. We are going to do a grommet later. Now let us go ahead and do the exploded view. We do new exploded view. The top, we lift it, right click, this side, go that is the x-axis. Okay, this is the skirting on the negative side. Okay, skirting, the z-axis, right click, this is the skirting, right click. Then the structure, we take it on the y-axis, but on the negative side. Click OK. Click OK. Now if we right click it, we explode it. Right click and animate collapse. Animate collapse. There you are. There you are. That's how your table looks like, right? That's how your table looks like. You can do it to make it go a little bit faster. You can do the speed at half. You can do it a closed loop. You can do it back and forth, back and forth. Yeah, whatever you feel like. GRP assembly, save the one. It really exists. There you are, and our table is done. Okay, our table is pretty much done. Now, thanks so much guys for your time. Let us meet in our next tutorial. Our next tutorial, we are going to be dealing with what is item number 3, which is our item number 2, and that is GR goods receiving trough sink. We are going to design a trough sink. Thank you so much. You might want to leave a comment there, whatever you want to say. I will try much as I can to review every comment. And yes, I did request you, I'm asking you, reach out if you know very well about weldments and the things that you've been seeing me struggle with, or anything to make me a better person as far as design is concerned. I really will appreciate. So consider subscribing also to our channel. See you next time. Have a good day. Thank you.